I really love these kind of problems. They look so small and look so simple, right? But there is often a neat trick hidden behind them to come up with an optimal solution. These kind of small tricks often help you to solve a bigger problem sometime in the future. I'm talking about a very similar problem on LeetCode, where you are given an array and you just need to find out the number of smaller elements than each element itself. Sounds so simple, right? Let's see how we can solve it. Hello friends, welcome back to my channel, a place where we explore the life of technology and make programming fun and easy to learn. First, I will explain you the problem statement and we will go over some sample test cases. Next, we will try to come up with a brute force solution to the problem and see the limitations around it. Going forward, we will try to optimize this solution and then also do a dry run of the code so that you understand how all of this works and it will stay in your mind forever. So, without further ado, let's get started. Let us try to make sure that we are understanding the problem statement correctly. You are given an array of integers, and for each element, you need to find out how many elements are smaller than it. So, if we look at our test case number 1, we have this array, right? And we have to determine a resultant array. To determine it, for each element, you need to find out the number of smaller elements than it. So, for element number 8, how many elements are smaller than it? 1 is smaller, 2 is smaller, 2 is smaller, and then 3 is smaller. That gives you a total of 4 elements, right? So you need to write down 4 in your output array. Next, go over to your second element, 1. How many elements are smaller than 1? None, right? So you need to write down 0 in your second place. Going ahead, you see the element 2. Now, this is a little tricky. How many elements are smaller than 2? Only 1, right? 2 is just equal, so you will not count it. And hence, I will write down 1 over here. Going ahead, I have 2 again. So this time, I will again have 1. Next, I have the element 3. So, how many elements in the entire array are smaller than 3? You have 2 2's and 1 1. That gives you a total of 3 numbers, right? So, you need to write down 3 in your last output. Once you have traversed this entire array, this resultant array is your answer. Similarly, let us try to look at our test case number 2. You have the elements 6, 5, 4, and 8. Start with the first element 6. How many elements you can find that are smaller than 6? That are 5 and 4, correct? So you write down 2. How many elements are smaller than 5? Only 4. So you write down 1. How many elements are smaller than 4? None, right? So you write down 0. And how many elements are smaller than 8? All of them. So you simply write down 3. This is your answer. Similarly, for test case number 3, you have all the elements as 7, right? So none of the elements are smaller. So in this case, your answer would be 0, 0, 0, 0, because you cannot find out any smaller elements. And thus, this will be your answer. Now, if this problem statement is clear to you, feel free to first try out the question on your own. If you are done, very good. Otherwise, let me show you what solutions I can offer you. Okay, so let us start with the first thought that comes to your mind. If you have to find out the number of smaller elements than itself, what will you do? If you have this sample array in front of you, then you will start off with the first element and you will start comparing each of the element. 1 is smaller, yes. 2 is smaller, yes. 2 is smaller, yes. 3 is smaller, yes. So you found a total of 4 elements, right? And hence you can start off by writing 4 in your answer. Now, moving on, you start with element number 1 and you will compare it with 8, it's not smaller, 2 is not smaller, 2 is not smaller, 3 is not smaller. So none of the elements were small, right? So you will write down 0. Going ahead, you start with element number 2. 8 is not smaller, 1 is smaller, 2 is equal, and then 3 is again not smaller. So you could only find one element, right? And thus you will write down 1 over here. Similarly, you will get 1 again, and you will get a 3 over here. This will be your answer. Now, sure, this method works correctly and it will give you a correct answer every time. But there is a problem with this approach. If your array is very large, for example, if I add all of these new numbers, then what will you do? You will start off with the first element and then you will compare it with each of the elements, right? Once again, you will start off with the second element and then again compare it with each of the elements. So what is happening over here? You are taking a lot of time just to compare all of the elements. And this solution will not be time efficient. You will take up a lot of time just to compare all of these numbers, right? And hence we need to improve upon it. What can we do about it? Let's take up a sample array once again. And whenever you're thinking about an optimal solution, just as a rule of thumb, try to think with your intuition. How can you approach the problem? In this problem, you need to count the number of smaller elements, right? And whenever you think about count, the first thing that should come to your mind is the counting sort algorithm. What did we used to do in that? We maintained a count of each of the element, right? And when we had to sort it, we just outputted all the elements in a linear fashion, right? You can check the link in the description below to my counting sort algorithm technique. But anyways, if you're given this array, what you can do is you can create a count buckets array. Now, this array will store the count of each of the element in the array. I have not started any iteration yet, correct? So the current count of each element is 0. What I will now do is I will start iterating through this array. I see the element number 8, right? So what I will simply do is I will increment this count by 1. Next, I see the element number 1. So what I will do is I will increment this count again by 1. Going ahead, I see the element 2. So go to index number 2 and increment this count. As soon as I increment, this would become 1. My next element is 2 again. So once again, go to index number 2 and increment this count. If I increment this count, it will become 2. Similarly, for number 3, I will increment the count at index number 3. Moving ahead like this array will become something like, right? And what this array is now telling you is you have 2 ones, 3 twos, 1 3, 2 5s, 1 6, and 1 8, right? You can verify it in your original array. Now, take a moment to think what this array is actually representing. You have 2 ones, you have 3 twos, you have 1 3, you have 2 5s, you have 1 6, and you have 1 8, right? Now, go one step ahead. Just look at element number 2. If you look to the left of this, how many elements you can see? You can see 2 elements, right? And if you look to the right of this, how many elements you can see? You can see 3, 5, 5, 6, and 8. So you can easily say that to the right, you have all the larger elements, and to the left, you have all the smaller elements. And in this question, you need to find out the number of smaller elements than each element, correct? So what if I do a cumulative sum of each of them? What I'm going to do is I will start adding these frequencies. So 0 plus 0 will give you 0. Then 0 plus 2 will give you 2. 2 plus 3 will give you 5. 5 plus 1 will give you 6. 6 plus 0 will give you 6 again. 6 plus 2 will give you 8. And then 8 plus 1 will give you 9. 9 plus 0 gives you 9 again. So look at these numbers again. What are they telling you? They are simply showing that you have 0 elements that are smaller than 1. You have 2 elements that are smaller than 2, and they are 1 and 1, right? Next, you have 5 elements that are smaller than 3. They are 2, 2, 2, 1 and 1, right? You have 6 elements that are smaller than 4. They are all of these. Once again, you have 6 elements that are smaller than 5, right? And if you move ahead, you can see that you have 9 elements that are smaller than 8. And all these are 9 elements. So now, if you have to come up with the answer, what you can just do is, you can start looking at all of these indices, and these values will be your answer. So if I have to come up with an output to this question, to find the number of elements smaller than 8, I can look at this index. The value is 9, right? So I can simply write down 9 over here. To find the number of elements smaller than 1, look at this value. That is 0. So I will write down 0 over here. To find the number of elements smaller than 2, you can look at this value. It's 2, right? Similarly, you can populate this entire array, and hence this will be your answer. Now, let us try to see how you can write a code for all of this. Okay, here we are. On the left side of your screen, you have the actual code to implement this solution. And on the right, I have a sample array that will be passed in as an input parameter to this function. What I do is, in this beginning, I create buckets for counting sort. So this will create my bucket array, and this array will store the frequency of each of the integer. I start a for loop to get this frequency of each of the element. Once this loop ends, it will store the frequencies. So now this array is telling me that I have 1 ones, I have 2 twos, I have 1 3, and I have 1 8, right? You can match it with the array. Now going forward, what I will do is I will do a cumulative sum. Now this cumulative sum will help me to count the number of smaller numbers than each of the element. So this cumulative sum starts at 0, then I have 0 plus 1, that will give me 1, then 1 plus 2, that will give me 3, then 3 plus 1, that will give me 4, this will be 4 again, 4 again, 4 again, and then ultimately 4 again. Now this array is telling me that I have 4 elements that are smaller than 8. I have 3 elements that are smaller than 3. I have 1 element that is smaller than 2, and I have 0 elements that are smaller than 1. Using this piece of information now, I can populate my output array. To find the output array, I will once again run a for loop, and I will create a result array. In this result array, I will look up all of these values in my count array. So for value 8, I will look at this value and I get the number 4. So I will write down 4 in my output array. For number 1, I will look at this index and I get the value 0. And hence this answer should be 0. Similarly, for number 2, I will look at the index 2 and I will get the value 1. So I write down 1 here, then 1 once again over here, and ultimately for 3, I will get 3. So I will get my answer and I simply return it in my output. Now, the time complexity of this solution is order of n, and the space complexity of this solution is order of 1. It works in a constant space. That is because in a problem definition, we are given that we can only have 100 unique integers, and they have a range of 0 to 100. So I will not be taking any extra space than order of 100, and that equivalents to a constant space. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, take a moment to think how we took advantage of the counting sort algorithm and arrived at an optimal solution. I have often heard that people say that quick sort and merge sort are the only important algorithms that you should know about. Yes, I know they are fast when it comes to sorting. But if you learn about all of these sorting algorithms, then you will also learn some very basic fundamentals that can help you to arrive at an optimal solution when you have some specific conditions around the problem. For example, in this problem, you were given a case that you can only have elements from the range 0 to 100. That narrows down your problem very much, and you can apply algorithms like counting sort. That is why I call them as building blocks or fundamental concepts. If you have them very strong, then you can easily solve bigger problems. What other methods did you come up with? And what other techniques did you try? What problems did you face? Tell me everything in the comment section below, and I would love to discuss all of them with you. You would be also glad to know that a text-based explanation to this content is available on the website studyalgorithms.com, a pretty handy website to help you out with your programming needs. You can find the link in the description below. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, let me know what problems do you want me to solve next, or rather, what do you want to learn next. I will be glad to help you out. Until then, see ya.